Welcome to part 2 of C++ memory stuff. If you haven't watched the first episode, you probably should first if you're not familiar with pointers at all, but if you already kind of are and just want to see stuff about shared and unique pointers, then this is fine. This is fine. Let's talk about shared pointers and C++. So the whole point of a shared pointer is basically to manage your memory for you. In general, in this day and age with C++, you should not be using new and delete anymore. Shared and unique pointers have, in general, replaced all that and make it a lot easier to work with. So yeah, I said it, all the stuff from the first tutorial is basically useless these days, but I learned it when I started learning C++ before learning all these shared pointers and stuff. So it's still good fundamental foundational knowledge, and this stuff you see in a lot of code bases still. But anything new being coded up in 2020 and later is probably not going to be using new and delete hardly at all, or any of that stuff, except in specific cases. You need to include the memory header. We're using standard IO just for printf. And let's jump into some examples. What is a shared pointer? How do you use it? Well, in general, you declare a standard shared pointer and you give it the type, then you give your variable name. You don't have to assign it right away, but it often makes sense to. So the way you give it an initial value, an initial declaration, whatever, is you set it equal to make shared of that type, and then whatever you want to initialize with. So floats can be initialized with nothing, and it'll be set to 0, or you can give it a value here of whatever you want to initialize it with. And this goes for any particular object, so you can make your own classes, make a shared pointer of your class, and use your initialization from your constructors there. How do you work with this shared pointer? You can think of a shared pointer as just a pointer in most cases, but it has just a few special things where, let's look at this function. So this is just a helper function, print shared pointer info, and we pass it stuff. And as you can see, it takes it by const reference, so it just has access to it but can't change it. And that's intended because, of course, we're just going to do some printing. So to get the value out of it, you use a star in front of it just like you would with a normal pointer, and you can see what its value is. Now this works because the shared pointer star is overloaded. As you can see, my little pop-up here on my IDE, it's basically overloaded to spit out the value on a float, or the value of whatever your class is. So this may or may not work depending on how your class is built, of course. And if you just want to get the raw pointer, you can use .get. So you can, I'm just going to show the address here in that printout, and you can see how many other pointers are referencing it, because the point of a shared pointer is to be shareable. So you can see how many other are holding a reference. The way the shared pointer works is it deletes itself when there's no more use cases. So because of that, it keeps track of its use count, and you can check at any time how many things are using it. And when everyone's done with it, it will clean up after itself. It'll call delete on itself without you having to specifically manage it. It's also this unique. This basically returns true if there's one, otherwise false. But you can see the other things available to it by using your IntelliSense or looking at the header. I like to use the IntelliSense, it makes it easy. So if you type in your shared pointer, hit your IntelliSense hotkey, which is Control Space by default, I believe, you can see some stuff. There's unique, use count, owner before, and some operators to get to the data. Let's run through all this, I'll walk through all of it, hopefully it all makes sense. I did build this other function just to grab it into another scope and make an additional one, so you'll see that. Alright, let's start walking. Let's start walking. Okay, the part everybody loves, walking through the code. So this is the first print here, is this block. And we see that we initialize it to 0, so it shows the value of 0. Shows the address, there's the address. Shows how many are currently sharing it, just one. Is it unique? True, because there's only one at this time. So let's look at what happens before we get to this next print. We just assign star stuff to 10. As you can see, this changes its value to 10, but doesn't change anything else. Then we call stuff.reset. What does reset do? Well, reset releases the data, basically. It says this shared pointer is no longer pointing at anything. But right after that, okay, so I should mention, if you call this reset and then you try to call a print on it, it's going to throw an error. So after the reset, we can set it to a new one. So that's sort of the point of reset, and then we'll get our info back out. Let me go ahead and get this back up again. There we go, we set it to 20, and we now see that the value is 20, and we see there's still only one reference. Alright, so we're going to start making more references and play around with that a little bit and see what happens. So we declare another shared pointer called other stuff, and we'll set it equal to stuff. So what happens here? Well, essentially it just makes a new one pointing to the same data. So now it'll have two references, and I also decided to set the value of the original one to 123 so that you can see that when you change the value that they're all pointing at, they all have that update because they're all pointing to the same data. All these shared pointers that have the shared count are pointing at the same data. So when I print for other stuff, but I've changed the value of the one at stuff, well, they're both the same. So you see that it gets the value even in the other one. And it also says it's the same address. They're pointing to the same address. And now it says shared count of 2 because it has incremented as it assigned another one, and none of them have gone out of scope. Now we go into another scope, pass it in the stuff value, create one in another scope, print it out, and then leave. So here's what happens there. We get to that new one, we print out the new one after assigning it, and our shared count is 3 at that time, not unique. And then we leave the function. So this other scope goes out of scope and should reduce the count again, which we do see. Now we'll call reset on this other stuff that we created as well. So that basically gets rid of its reference count. Without it going out of scope, you can call reset and it gets rid of it as far as the reference count. And then we do one last print on the original, and we see that there's now only one. It has all those new values and it is unique. So that's in general kind of how you play around with shared pointers, and how you can use them to share access to a data and have it be automatically managed without having to call new and delete. It'll just delete when there's no more references. So it is a data type that can be less code intensive and less brain racking to try to keep track of all your new and deletes. You just share the pointer as needed, and when it's all done it cleans up after itself. It is actually quite nice. So is there a drawback? Well, yes, but it's very small. And it's basically the size of these shared pointers is like, I think it's double. So it takes up a tiny bit more memory, but the trade-off is pretty valuable in my opinion. I like using shared pointers. Let me know if you have any questions down below about shared pointers and how to use them. And of course there is reference documentation if you want to read more about them. Now let's try something with unique pointer instead. So unique pointer only allows one reference at a time to control the memory. And when it goes out of scope or you reset it, the data gets deleted. So unique pointer is more for isolated control. One thing controls it at a time. So let's just do a thing where we rename everything we've typed as shared pointer to unique pointer. So as you can see, it doesn't like this make shared anymore. Naturally, we have to use make unique now. And also you can see that it doesn't like some of these other things that shared pointer offered, like you can't just set it equal to another one. That doesn't work. You have to release control from the original if a new one is going to take control of it. So we can't, there is no use count anymore. There is no unique because it's always unique. The use count is always 1. So what other options do we have? Let's take a look by checking with our IntelliSense, and we can see that there is a lot less. There's get, which gets the raw pointer. There's get deleter, as you can set up custom deleters for your unique pointers. Yeah, I guess I'll get into that a little bit, but that's where it starts getting a little more beyond beginner. Well, we'll dig into it a little anyway here in a minute. Let's just delete those. We can see value and address up. Admittedly, there's a lot to these pointers that it's hard to show everything in one quick example, but I'll try to at least give you the main stuff, and if you want to dig in and read more, it's cool. You can do that. So let's go ahead and run this, and I'll just walk through all this code, and hopefully that is enough to make it a little more transparent for most of you. So yeah, unique pointers. Only one copy allowed, only one controller of the memory, so you got to have ways to mess with that. Let's take it from the top here. First, we make a unique pointer called stuff, and we just give it the default float constructor, and then we check its value. So all this does is print its value and its address of whatever that unique pointer is, and we do that by dereferencing on the value and just getting the pointer to get the address of it there. And we see right off the value 0, which is expected, and we have an address that is some interesting bytecode. And then next thing we do is we assign stuff to 10. So we can dereference it to do that. You can see it's an overloaded operator on there for the unique pointer. And yeah, there we go. Still the same address, new value. And then we call reset, which will basically gets rid of whatever was currently there and sets it to null. So if we try to do a print right after this reset, we throw an error because it's a null invalid memory. So this reset will deconstruct it and all that for you if you need to. But we're going to go ahead and reassign it on the next line here with a new one, or just a new unique float of 20. And then we print it, and as expected, we get the value of 20 and still the same address because it's still the same pointer. It just is pointing to new data since we reconstructed it. And now let's go to this next example. We create another one called other stuff, and we're going to assign this. We're going to make a whole new one, but we're going to assign it the value of stuff.release, and then we're going to dereference that value because this release returns a pointer to whatever the type is. So it releases control of it, so it will destruct and deallocate all the original stuff. But it's going to end up returning a pointer, and we're going to dereference that pointer to get the value of what would be currently 20. So this will ultimately just be 20, but also in the process it is releasing the old stuff. So stuff is going to be null after this. So we have this new other stuff. Anyway, we do a print after this just to check the stuff that we released, and we're just doing a boolean of a get of the pointer. So that way we can see if it's null or not. If it's null, this will be false or 0, which we see here it is 0. So yeah, it did indeed release it. And then we're going to go ahead and print the info of this other stuff, this one we constructed, and as expected it is the value 20, but we do have a new address as we're allocating a new unique pointer. So this old one is just done basically for now. So we're going to go to another scope. We're calling the function another scope, and we're passing in this other stuff pointer, and we're going to see what happens. So what this another scope does is it takes a reference to a unique pointer, and it basically constructs a new one by moving the old one into it. So this move semantic will actually destruct the old one. So that's another interesting thing, is if you do a standard move of a pointer to a new one, you are moving that data to the new one, and the old one is no longer pointing to anything. So since we're doing this by reference, we are literally editing this original pointer we're passing in. And then we're just doing a print info, this one we just created. And as we see, now this is where it gets interesting with this move. And we still have the value, that's expected, but also we have the same address on a different pointer, and that's because we did the move. So we just, moved the data. It's confusing. A move sounds like you would shift the data somewhere else, but actually it stays in the same place. It's more like it moves this pointer or this new one to the new space. It's just weird to have a function called move that doesn't move, or you have to think of it backwards as it moves your pointer to where it is rather than, yeah. All right, enough of that. So as you can see, we have the same address and stuff. And now we'll go down to the last of it. We're just checking if these are null or not. So this other stuff is, now that we have moved it somewhere else, it is now null, as we see there. And the original stuff, of course, is null. And this one, since it goes out of scope right at the end of this function, is null, and we actually have no unique pointers allocated by the end of this. And here's the other example. This is basically the en.cppreference.com, the unique pointer, all the details about it, and it tells you all the stuff. There's release, there's reset, there's what it does. This is always a great place to go if you're not sure about stuff or want to learn more about what these do. And you also see it as a get deleter, so you can assign functions to run your deletion function. By default, it just calls delete, but you can make your own custom one if you want to log or whatever, or do something special, and you're going to see that in this example. But anyway, we can just run it in their little online thing, GCC something apparently. They don't have the MSVC one in here, which is fine. It should essentially do the same thing. So I hit run on here, and I got all this stuff at the bottom. So we can kind of walk through this and see what it's doing. Let's just start at the top of the main. They've got all sorts of examples here. This might be a little long-winded, but it's going to be some great examples of the things you can do. So first of all, we just got the standard cout, unique ownership semantics demo, auto p. Yeah, that's another great thing. Instead of retyping this whole standard unique pointer, you can often just do auto and it knows what you're doing because of this make unique, or that you're passing it a unique pointer. So auto is super nice when you're working with these pointers. So the first thing it does is, let's see, it just makes a unique pointer of this D class. And this D class, where is it here? It's okay. So we've got this initial, we're getting a little polymorphism here too. That's interesting. So yeah, we got this virtual class here. This one will say bar unless you redefine it with an override. So they've made a new struct and inherited B and said, hey, we're going to override this bar function and say it's D bar. So that way you can tell which one you're in. And the constructors just have a little C out that says what you do. So our original C out is just this D thing. Let's look down at the code and see what we're doing. We're doing a pass through move for this auto Q. Where the heck is that? So I feel like this is a really confusing demo. Okay, we're just calling it directly in this pass through. So they're passing this. Apparently you can do it by value or R value. They're just not even doing it by a reference here, which is interesting, but it's okay because it's only copying a small tiny pointer, I believe. Anyway, P bar is what they call, and that's where we get this second one here of it saying bar. And then we're returning this pointer. They are doing a move, so that's actually a big deal, and this move is why they can do it by not reference, because they're literally saying this is now that. So basically this Q is going to become the new one, and there it is. So they're asserting that first of all that P is done because yeah, you moved the pointer out of it, so this one's done now at that point. And then they call the Q bar, which is this right here. Now let's continue on with our main. Oh, okay, then they deconstruct it, which it shows right here because they got a little C out in that. Hope this is all making sense, but yeah, it's just calling this one at the end here. So they're just messing with their own little custom class. All right, let's look at the runtime polymorphism demo. So let's see if we can figure out what all this does. First of all, they're declaring a unique pointer of this original class of B, which has two virtual functions, and they're making it a unique D, which is something that inherits it. And as you can see, it constructs this D class. But what do we do next? We dispatch this P bar, and we get the D one. And let's see what other cool stuff. Yeah, this is neat to have a little polymorphism sample in here. They start messing with vectors. They say, okay, unique pointers can be stored in a container like a vector. A vector of unique pointers for B. They're calling the vector V, and they're just pushing back a brand new make unique. And as you can see, it constructs it right there. And they're pushing back a new one, except this time they're moving P. And as you can see, it does that. And then they're doing an in place back, which this one will also construct a new one. Well, I think actually this one right here doesn't construct a new one, it just moves one, so it doesn't say anything. This one here is going to make a new D, which is going to call that. And then they do this bar 3 times, go through each one of those so that's going through all three of those, dispatching whatever that. And then it destructs all 3 of them at the end because they go out of scope with this bracket. So there's the 3 destructions. All right, so next, custom deleter demo. Now they're doing it on a file. I'll walk through all this and try to make it make some sense. So custom deleter demo, and they make a new output file stream of demo.txt, and they output an X. So then what they do is they make a unique pointer. The type is file, and their custom deleter is this decal type close file reference. Now if we go look at this close file, all it is a function. Let's go find it, close file. There's the function. Takes a file pointer and it just calls close on the file pointer. So when it destructs, it'll close the file is the point. So you can give, let's go find where we're at. Here we are. So yeah, you can give it a function to run. You can put lambda in here. You can make your own function. But apparently, if you just made a function, you have to do this decal type and reference thing to it. There's a ton of examples out there, and here we go. They call it this unique pointer FP, and they give it this f open and close file as the stuff to construct it. Then they just go to if open, basically do a standard cout get char, and then when they do the cout of the get char fp.get, that's where this X comes from. All right, and then f close, it should close all that stuff. Let's see, f close called here, but only if file is not null pointer, because that's what the function does, I believe. Yeah, that's a bit of a harder one to understand, but it makes some sense. Okay, let's look at this custom lambda deleter demo. Okay, so we go to this unique pointer, type is D, and here's the function, standard function void D star, and there we go. Give it a new D, and here is the custom deleter. Starts a lambda, capture this D pointer and called PTR, and then when this custom deleter runs, it'll say destroying from custom deleter, and then actually delete the pointer. And so we call p.bar, so we should get, okay, so there's construction, there's the p bar thing, and then here's where the destructor is called, and it's right there. All right, now array from a unique pointer demo. All right, let's look at this one. So we're, okay, this is a little different. This is an array. We're making a unique pointer that is an array, and we're giving it 3 little items there. So when it goes out of scope, it's gonna, well, it constructs 3, then it deletes 3. So you can put arrays in these unique pointers too, which is pretty interesting. And the linked list demo looks like it doesn't spit out anything here. It just does something. What are we doing here? Linked list for long and is giant number. L push N, destroy all 1 million nodes. What? Well, I'm not sure what the point of that little demo is right there. Let's see. Let's look at the list up here. They have some list thing. Here we go. Oh, okay, so they're just using some unique pointers in a struct called a list that has nodes, and I guess it's a pretty standard list thing. I don't really want to walk through this one. They don't have a cout to follow. I feel like it's just going to make it confusing if I try to walk through that one. Alright, well, I think that's enough of this video. Thanks for watching. In the next video, we are going to probably be looking at how Unreal keeps their life cycle of stuff. We're going to be digging into their source code. Hopefully it's open enough for me to be able to do that. But we're going to be looking at some real world cases of managing memory with C++. Thanks for watching. Matt from Code Technotorials over and pretty much out. But before I am finally out, I'd like to give a shout out to my Patreon, Nasser Al-Howdy, over on Patreon. Link down below if you'd like to join. He has made this episode possible. If you like this sort of content, please don't forget to like and subscribe so you can see when I come out with more. Thanks for watching. Peace out, everyone.